Hello friends, let us now learn some important points about the anode. In the last class we have learned about the cathode. Now let us learn about anode. Before we go about anode, we start learning about anode, we should learn something about the focal spot. Not the focal spot size, but what is focal spot? Focal spot is the area on the tungsten anode where the electrons will come and hit the anode. So the spot or the area where the electrons will come and bombard the cathode, that is called as focal spot. So at the focal spot, that is at the at this anode, most of the energy, the kinetic energy of the electrons is converted into 99% of the kinetic energy of electrons is converted into heat, whereas 1% is converted into X-rays. So because heat 99% is converted into heat, so there is lot of accumulation of heat is seen at the tungsten anode. So this accumulation of larger amounts of heat might damage the tungsten target. Normally the tungsten has a melting point of 3370 degrees Celsius. But it is better to keep the temperatures below 3000 degrees Celsius. So we have to prevent the decrease the temperature to 3000 degrees Celsius. So for decreasing the temperature, we need a larger focal spot, right? One more important thing is that if there is larger focal spot, then there will be decreased radiological detail will not be good. So for having good radiological detail, we need smaller focal spot. So at the same time, we should achieve these both targets. That means we need a larger focal spot to dissipate the heat generated at the anode, and at the same time we need smaller focal spot to maintain good radiological contrast and radiological detail. So for this there is a principle which is developed called as line focus principle. So what is this line focus principle? In line focus principle, the the focal spot is the shape and size of the focal spot are mainly determined by the shape and size of the electron beam. The size and shape of this electron stream is mainly depends upon the cathode filament and the focusing cup and the position of the focusing cup with this cathode filament. Now, one thing that we can do is these electrons, when they bombard the target anode, now the anode is inclined at an angle, and the angle at which the anode is inclined, this is called as anode angle. This anode angle will differ with different types of tubes, and this may vary from 6 to 20 degrees. So because of this angulation, one thing that has happened is focal spot. If you view the focal spot from the direction of X-rays, this is the big large focal spot. Whereas if you try to view the focal spot from the direction of X-ray production, this is the focal spot. So this is the focal spot in the direction of X-ray electron production. This is the focal spot that we got when electrons are produced. This is the focal spot if you view it from the direction of X-ray production. So from the direction of X-ray emerging, we can see that the focal spot is made smaller, and at the same time from the direction of electrons the focal spot is large so that it can dissipate the heat. So this is called as line focus principle. That is, by inclining the anode at an angle, the both properties of focal spot, that is larger focal spot for dissipation of electrons and smaller focal spot for smaller apparent focal spot for the good radiological detail have been achieved. And in the present day, 6 to 20 degrees is the focal spot size that has been recommended. So most of the diagnostic radiology, we have focal spots of around 15 to 20 degrees. There are also few focal spot, few X-ray tubes with focal spot with only 6 degrees also, but it is better to maintain at 15 to 20 degrees, especially for our diagnostic radiology. So this is about the apparent focal spot. Now, followed by apparent focal spot, now let us now learn the differences between, there are types of anodes. So this is the anode. Anodes can be divided into two types. We have stationary anode and we also have rotating anode. Okay, first in the stationary anode is this one. This is the stationary anode. Stationary anode mainly contains the tungsten filament. Sorry, tungsten. It has a tungsten. This one is tungsten, and this tungsten is actually a small plate, and this small plate of tungsten is almost 2 to 3 in thick, and this is embedded in a large mass of copper. So a small plate of tungsten is embedded in a large mass of copper, and the dimension of this copper is almost or more than 1 centimeter. The dimension of tungsten is very large. It's large, okay, not 1 centimeter. We don't have actual values, but it is large. And then the tungsten and then the anode is inclined at an anode angle of 6 to 20 degrees. Here, what is the reasons for choosing tungsten uh, as a target anode? One, tungsten has a higher atomic number of 74. So as a result, this higher atomic number is good for production of X-rays. Number two, the tungsten has higher melting point. The melting point of tungsten is around 3370 degrees Celsius. So it can withstand larger temperatures the before the tungsten gets melted, and as a result, it can rapidly dissipate the heat away from the target area. The tungsten is bonded to a copper here. If you see the copper is a good conducting agent. Because it is a good conducting agent, it can dissipate the heat towards itself. It can, it can absorb the heat from the tungsten, because copper is a better conductor of heat. So as a result, because of the good thermal conduct capacity of the copper, and this copper is made to be larger block, so as a result it can increase the speed of cooling. So the actual size of the tungsten target is larger than the area bombarded by the electrons. That is because if you see the copper, this copper melting point is around 1070 degrees Celsius. So if the copper is heated to more than 1000 degrees Celsius, it will melt. So the electrons which are bombarding the tungsten target, all the heat is absorbed by the tungsten. This heat should decrease. The heat should definitely cool down. There should be decreased heat, and the heat reaching the copper should be less than 1000 degrees Celsius. If the heat reaching the copper is more than 1000 degrees Celsius, then the copper will melt. So our aim is to make the tungsten target a little thicker, sufficiently thicker, so that it can sufficiently reduce the temperature to less than 1000 degrees before it reaches the copper anode. Okay. Then one more important thing is, as we have already said, metals will expand on heating. So the coefficient of expansion of tungsten and copper, both these are also not similar, not same. As a result, sometimes the tungsten might come out of the uh, tungsten might leave, or it might um, peel away from the copper anode. So that is one of the disadvantage. So to overcome these disadvantages of the stationary anode, now a rotating anode has been developed. Right. What actually happens is, if you see this tungsten, there are two major problems in this tungsten copper anode. Number one, heat dissipation. This heat generated at the anode is one of the property which is limiting the X-ray tube usage. So, and that is one. Number two, copper and tungsten, because of having their different coefficients of expansion, they both expand at different rates. As a result, the tungsten might peel away from the anode. So to prevent this, we have developed a new thing which is called as rotating anode. So rotating anode is actually, it is like this. It is actually a disc of tungsten, or it is a disc of tungsten, or it can be made up of alloy of tungsten, and it will rotate at a speed of 3600 revolutions per minute. Generally, in this is theoretically, but practically it will never reach 3600 rotations per minute because of friction and other causes. It will not reach this high rotations per minute. The speed will be around 3000 rotations per minute. So the tungsten disc is made to have a beveled edge. If this is the tungsten disc, we have already learned about the line principle, line focusing principle. So the tungsten disc is made to have a beveled edge so that the anode angle is maintained, so that the actual advantage of line focus principle has been obtained. So the purpose of this rotating anode is that if the anode is rotating, the cathode is made very small and anode is made very large. So X-rays which are produced, they will strike the anode at a particular point only, this point only. Whereas the anode will be rotating. So as a result, the electrons will not strike the target at the same time every time. They strike the target at different spots at different places. So as a result, this will allow in faster dissipation of heat, and this will help in mm, saving the anode also from more heat. So now this, how are we going to rotate this tungsten anode disc? One way of rotating this tungsten anode disc is by using the stator of induction motor and stator of induction motor. So what we do is there is stator coils which surround the neck of the X-ray tube. So this is the neck of the X-ray tube. We have stator coils which surround the neck of the X-ray tube. These are the stator coils. When electricity is passed, when current is passed through the stator coils of induction motor, these will produce the magnetic field. When magnetic field is produced, this magnetic field will induce the current in the induction motor. When the magnetic field induces current in the induction motor, then the copper rotor present in the induction motor starts to rotate, which will rotate the anode assembly. Now, one important thing is about the induction mode. This is the main mechanism. Now, this anode disc and this anode stem, this induction motor and the anode disc are connected by this anode stem. This anode stem is made as small as possible so that it can rotate very well. Then, one more important thing is that here there is copper rotor, right, which rotates, which causes the tungsten to rotate. One important problem with rotation is that there will be development of friction will develop in the rotating anodes. So this friction will decrease the short life of the tube. So we have to lubricate the bearings or connections between this induction motor and the target anode. So we can use different types of lubricants. Initially, oil was used as a lubricant to lubricate this induction motor and the target anode. But oil will vaporize. So once oil vaporizes, again the friction will come back. So as a result, we stopped using oil. But we started using graphite. that later graphite will also vaporize. When graphite vaporizes, it will form powders. Because there is vacuum, there is powder uh, which is circulating in the X-ray tube. When powder is circulating in the X-ray tube, the electrons which are produced at the cathode, they will start bombarding the powder. And as a result, the electrons will lose their energy before it reaches the anode. So as a result of this, the X-rays are not efficiently produced. So we stopped using graphite. Nowadays, we use silver as a lubricant. So silver as a lubricant will prevent the friction or will reduce the friction between at the anode stem between the target anode and the copper rotor in the induction motor. Then one more important problem here is the heat dissipation. Heat dissipation. As we have already said, the when X-rays are produced, when electrons strike the anode target, 99% of the energy, kinetic energy of electrons is converted into heat, whereas only 1% is converted into X-rays. So, so we have to, so the all the heat will get, though the electrons will strike the target anode at different points and the anode is rotating, but at one point the whole anode will get heated. So when anode is heated, the heat will be dissipated to this anode stem, and from there to the induction motor, and from there to the whole X-ray tube. So to prevent that, we have to solve that problem. So to prevent that, this tungsten target and the induction motor are connected by this anode stem. This anode stem is made up of molybdenum. Now this molybdenum is a metal with high melting point of 2600 degrees Celsius, and it is also a poor heat conductor. Because it is a poor heat conductor, this molybdenum uh, them will prevent the heat from reaching the induction motor, because once the heat reaches the induction motor, this will decrease the working of the induction motor. So by this we can prevent the heat from reaching the induction motor. Then one more important thing is the length of the molybdenum stem. If the length of this molybdenum stem is increased, then the inertia of the tungsten load also increases. So when the inertia of the tungsten load increases, then it will take time for the tungsten to move while before it is rotated. So to prevent that, this anode stem is made as short as possible. It is made shorter. Then Then one more important thing is that for what actually happens first there is stator of induction motor. Current will be passed through this coil, and this will produce magnetic field. This magnetic field causes the induction motor to the current to pass through the induction motor. This current will rotate the copper rotor in the induction motor, and this will result in rotation of anode. For all this to occur, there is at least 0.5 to 1 second will occur. So during this 0.5 to 1 second interval before the anode rotates, the electrons should not flow from cathode to anode, because electron flows from cathode to anode even before the movement of anode, that is even before the anode rotates. Then what happens, the x-rays are produced and electrons will bombard at the same site, and this will cause damage to the anode. So to prevent that, the x-rays should, the electrons should strike, or the electrons should only strike when the anode rotates. So for that we have put a safety circuit. So this safety circuit is incorporated in the X-ray circuit to prevent the X-ray exposure before the rotation of the anode assembly. Then slowly what happened is, as the age of the anode increases, the electrons will start striking the anode. So this has resulted in roughening or pitting of the anode tube. So when this anode, rotating anode, becomes pitting, So that means there is formation of depressions are seen over the target rotating anode. So when electrons will hit these depressions, these electrons will result in production of X-rays in different directions. So this is not what we wanted, right? We want the target anode to work for a longer time. We do not want to distort the surface of the target anode. Because of repeated exposures of target anode by the electrons, these electrons will hit the target anode with a high amount of velocity, high amount of kinetic energy. So these will cause pightening and roughening of the anode surface. So to prevent that, we have started using an alloy of 90% tungsten and 10% rhenium. Using 90% tungsten and 10% rhenium, this made the anode to almost more resistant to surface roughening and surface pitting because of the high thermal capacity. Next, the anode will rotate. This anode rotation is between 3000 to 3600 degrees rotations per minute. But if the speed of the rotation increases, then the target area will there will be very short period for the electron beam to hit the target area. So as a result, there will be more the electrons will not hit the target area at a specific spot. So today there are X-ray machines which have the rotations of anode of around 10,000, rotating at around 10,000 rotations per minute. So increased velocity, making the anode stem as small as possible, and also decreasing the inertia of the anode. All these have made the anode assembly to work properly. Right. Nowadays, there is one more thing that has developed is the compound anode disk. So in compound anode disk, here what we have done is we have made an anode disk with a thin plating of tungsten along with molybdenum. So this is a compound anode disk. Molybdenum has a specific gravity of 10.2, whereas tungsten has a specific gravity of 19.3. So this compound anode disk will decrease the weight of the tungsten and molybdenum, and it will prevent the heat from dissipating into the molybdenum. At the same time, the tungsten, because of the decreased weight, the tungsten can achieve higher velocity. So as a result, this will increase the shelf life of anode. Next, second, nowadays we have also started using tungsten with rhenium alloy. This tungsten with rhenium alloy is a better target for electron beam, and there is also usage of copper or carbon also. Instead of molybdenum, a few compound anode discs were developed with carbon or graphite with tungsten. Because this graphite is even lighter than the molybdenum. So as a result, this will also help in better dissipation of heat and to increase the velocity of the rotating anode. So these are the important points about the anode. Thank you.